All right, it is 9 and people are starting to show up. So I think we can go ahead and get started. Let's see. I guess first of all, can someone throw in the chat that they can hear me okay? And that they can see my screen?
Yep, can hear you and see the screen just fine.
Great. Thank you. Well, to the group of you who are here and people are slowly filtering in, thank you very much for coming. I initially just want to apologize for the Outlook issues over the last couple of days. There's not a good solution that we've found yet for external stakeholder groups of kind of mixed, Google and Microsoft and federal and non-federal and that sort of mixed group for these kinds of meetings. So if you have any suggestions for how to cleanly manage a group like this for planning a meeting and things like that, I'm all ears. But thank you all for coming and attending to sort of learn what we're going to be doing in 2025 with Colorado Airborne Snow Measurement Program. The meeting is currently being recorded and will be posted on YouTube when we're done. Our YouTube channel is linked to the CASM website, which I will throw in the chat now. Easy to remember, coloradosnow.org. But we'll put the meeting up and have sort of defined breaks within it, so it's easy to sort of search through the meeting if you have to drop off for whatever reason. But thank you for coming. Now. The other thing we're going to do throughout this will be a Mentimeter poll, so kind of an interactive poll, and we'll show some live results to kind of get a sense for who you are, what some of your goals are around improved snowpack measurements, and your thoughts on overall program direction. I'm going to share one link in the chat here, and then keep that window open on your computer because we'll go back to it. And if you go back to it a second time, you might have to skip through a few questions. So there'll be a Mentimeter poll that we come back to a couple of times. Just be ready to use that same page again. And so with that, just a quick overview and agenda. In general, like I said, meeting recording will be uploaded to YouTube. Starting now, we're going to go through kind of a welcome and introduction. Jeff and Dave Gotchis are going to give an overview of the ASO technology and forecast system. And then Eric Sky and I will give an overview of the CASM program itself. By 10, we'll be to the point of going through some case studies. There's a number of users that have been applying Airborne Snow Observatory's data products, including snowpack and streamflow forecasts, to their water resources decision making, which is really what we want to see. And I feel like every one of these meetings, there's just that many more people that are using it. And so it's heartening to see, but this is also to give you all a sense of what people are doing with the data and to give you some ideas for how you can use it yourself. So as we go through, if there's any ideas you have or anything that jumps out at you, feel free to ask questions in the chat or throw in some comments about how this could apply to you. We will get to chat questions kind of as we have a chance, but definitely put them in there if you have any questions or comments about how this affects your organization. And then 10:45 or 11-ish, we're going to get into sort of program growth and management opportunities for the CASM program. And that's from ASO Inc., CWCB, and myself at LRE Water. And then we should wrap up by 11:30 or so. Hopefully we have enough questions that we go to the end of the time. We're scheduled through noon, but we'll see where we get to. Before I go farther, though, can anybody who is on the CASM planning team unmute, turn on your camera, and go around and quickly introduce yourself?
Sure, I'll kick it off, Paige. I'm Eric Sky with the Colorado Water Conservation Board, helping manage this program from the state side of things. My counterpart at the state is Andrew Rickert. Unfortunately, he couldn't be here today as he's actually out doing the thing. He's running a snow course this morning. So thank you all for attending and looking forward to today.
I'll jump in. Yeah. Scott Griebling with the St. Bernard Left-Hand Water Conservancy District. Unfortunately, I can't stay on for all of this, but wanted to hop on for the first part.
Hey, everybody, Ken Curtis from Dolores Water.
Morning, y'all. Jeff Deems with Airborne Snow Observatories.
Nathan Combs with the Caness Water Conservancy District.
All right, thanks, guys. There's a few more people that will hop on a bit later, but yeah, let's get into it. So first off, I'm going to throw this link in the chat here, but this is a Mentimeter poll. So please open this link, and then we will go through just a quick poll of kind of who you are and how you've come to this. We're going to see if this works on the first try. So who are you and who do you represent? So yeah, go ahead in the chat, just identify yourself and your basin. I think one of the things we pride ourselves on with this program is that we do have representation from basically every basin in the state. The Republican River, unfortunately, doesn't have a lot of snowpack, so not a lot of representatives there. And the North Platte we're trying to engage with more, so maybe we, not sure if we have any North Platte people here today, but in general, yeah, we like to see that we have people from everywhere around the state and out of state, depending on kind of the federal work that you do or other groups you're with. So yeah, we'll just give it another sec here. Yeah, I think South Platte and Colorado is pretty common to have lots of representation there, given the population centers and sort of contentious issues on the Colorado. But yeah, having representatives from every major basin is great. The form does not allow multiple select for the basins. That's okay. Pick your primary basin then. It's not a perfect poll. Sorry about that. Okay. Give it another 30 seconds or so and then move on. But yeah, good representation from around the state. Love to see it. So everybody can go on to the next question. And I think some of you have already kind of jumped into this. What sector do you represent? Are you water management, agriculture, research, recreation, policy, other? I tried to create this question with a multiple choice with selections and ran out of options because there were just too many choices for how people come to the CASM program and really what people do at their respective agencies. So seeing a lot of interesting results here, a lot of water management as expected, but science, research, and modeling. We have some policy NGOs, federal, CWCB, floodplain management, conservation, water schedule for FRI-ARC. That's cool. I think we're trying to engage with FRI-ARC folks a bit more. We haven't had that conversation really yet. Yeah, ag, local government. So a lot of good responses here. Thank you. And then in 3 words, it seems like people are kind of already answering these quickly, but that's okay. In 3 words, what's your biggest priority this snow and runoff season? And I'm seeing a lot of skiing and I love it. But yeah, forecast, we see timing, runoff, volume. SAR, that's interesting. I wonder who put SAR as their answer. And is that synthetic aperture radar or is that search and rescue? Why don't you throw that in the chat if that's what you do. But I think what I'm seeing here is the trend of improved forecasts of runoff timing and volume and peak runoff, which is exactly what we're hoping to, the exact kind of data products we're hoping to deliver to help you all make better decisions. All right, snowmobiling, nice. Farm, yeah, miracle. Yeah, a big year is always sort of, something we're hoping for. All right, well, thank you. So again, keep this window open. Keep your Mentimeter window open kind of separately. We don't need to go on past this question, but we'll come back to it later and walk through some of these results. But don't feel like you have to answer the whole quiz just yet. So I'm going to stop presenting here and switch back. All right, so with that, I'm going to queue up Jeff Deems here to give an overview and implementation of Airborne Snow Observatory's technology. So Jeff, you should be able to share. Let me know if you can't, but you can take it away.
Working on it. Give me a second. All right. Looking good?
Yeah, looks good. Thank you.
Great. All right. Thanks, Paige, for getting us rolling here. Thanks for everyone, for attending today. I think this is a great program because we get to talk about not only what the program does, but seeing some impacts of it with some stories from a lot of the folks who are putting these data sets to work on the ground. For those of you who attended the workshop at Water Congress, you'll see some similar content, but looking forward to broadening the discussion here. So I, along with our operational predictions lead, Dave Gotchis, will run through a brief overview of ASO, both the airborne measurements, data products, and the runoff forecasting capacity, and to get us all on the same page here. I think by this point we all are having the same motivation here, and that is to broaden our understanding of the mountain snowpack, our biggest seasonal reservoir. The complexities of the mountain snowpack in space and time are a pretty difficult thing to capture. It changes rapidly during both the accumulation and melt seasons, and with those changes having big impacts on our ability to forecast the timing and magnitude of snowmelt runoff. Looking into the Upper Gunnison Basin here with Crested Butte at the top, the East River is typically represented by a couple of snowtel stations, Butte and Schofield Pass. This network, the snowtel network, as well as the manual snow course time series, really are the backbone of our understanding of the mountain snowpack over many decades, and continue to serve a critical function in continuous monitoring of the snowpack. What they miss, of course, is the spatial picture, how the snowpack varies across the landscape. And I think it's pretty easy to see looking at the image in the snow depth image in the background, that the full spectrum of how the snowpack varies would be pretty much impossible to completely monitor with a station network. So really what we need is to add to that picture, the continuous in time picture from the snowtels, with a spatial understanding. And the reason we need to do that is because we need to make sure that we're capturing all of those mountain snow dynamics, how it changes over time, so that we don't get surprised by a snowpack that isn't well characterized by the station locations, or is doing things differently than it's done in the past. And here's an example from that same basin, the East River, looking in plan view now, and comparing the two most recent water years, 2024 and 2023. The average of the two snowtel sites there, marked with the red X's, is shown in the time series plot on the left, with blue is 2024, green 2023, and you can see the median trace there with the dotted line. 2023, obviously a much bigger water year, well above the median. 2024, though, stayed at or above median until its peak, with maybe a little early melt onset compared to the historic average. We flew in both years in the East River, 2 flights one in early April, one in late May, a couple days apart from each other year to year. And if we look at the map on the right, this is the difference in water equivalent between those 2 years. So brown means that 2023 had more snow, more water equivalent than 2024. Big picture, lots of brown on that image, agreeing with what the 2 snowtail stations are telling us, that there was more snow in 2023. But looking at the spatial pattern, it's quite interesting. On the western edge of the basin in the Ruby Range, the differences are huge. In fact, I could have plotted this on a broader scale up to a meter of SWE difference, such as the magnitude of the SWE difference in the Ruby Range. On the east side of the basin, however, there's a lot of white colors showing not much difference between the 2 years. And the 2 snowtail sites do show a little bit of that longitudinal change, but they're also at different elevations, making it fairly difficult to tease out if it's really this east to west gradient or an elevational gradient that they're sampling, likely both. But this difference across the basin is important for administration of water within the basin. The total basin difference is 131,000 acre feet, and I think that's reflected well by the magnitude of difference in the snowtails. That's early April. If we move into late May, that east-west pattern still persists, although it's much lower magnitude in the west, and it's actually switched sign in the eastern part of the basin. Brush and Cement Creeks now have more snow in 2024 than they did in 2023. Something that, again, is not reflected in the station network, even though the stations are still showing that that the total basin SWE, they get the magnitude, the scale right between the 2 water years. Again, critical, especially as in late May, we're starting to get into the meat of the runoff season and irrigation season. And those in the basin, depending on runoff from Brush and Cement Creek, are seeing a much different picture than those depending on Coal and Slate River. So just an example of how the spatial picture, being able to capture the spatial picture, really adds another dimension, literally, to our existing data streams provided by the NRCS. This ability to capture the SWE volume translates directly into our ability to forecast seasonal runoff. Example here from the Blue River, but we could make a table like this for any basin in the state, with some strong variability over time in that annual forecast performance. April forecast volume relative to observed, in this case, inflow to Blue River. And there's a number of impacts that, or a number of factors that impact our ability to forecast accurately. Future weather, of course, is a big one that's common to any forecast technique. We don't have a good handle on what the weather's going to do from April 1st all the way through the end of August, or end of July, I mean. But other things that complicate the relationship between some point measurements of snow and seasonal runoff, like changing temperatures, changing precipitation patterns, the impacts of dust on snow, and changing watershed conditions from fire or beetle kill, also affecting snow accumulation and melt dynamics. All of that goes into influencing forecast accuracy year to year. A key, though, is that knowing how much snow is up there gives us the best possible foundation on which to minimize those collective errors going into the forecast. A couple of years in comparison here, looking at ASO water equivalent compared to River Forecast Center water equivalent, which is derived from snowtail precipitation measurements. 2021, I'm looking at the center plots here, which compare the SWE values. In 2021, the RFC water equivalents were largely overestimating how much snow was in the watersheds. This is statewide for these SWE plots. Whereas on the bottom plot, 2023, they were largely pretty accurate, doing a good job of reflecting how much water was out there. That's reflected in the forecast traces as well. If we look on the left panels, this is for the Roaring Fork River forecast and observed flows, but the same pattern existed statewide. In 2021, with the overestimates of water equivalent, the forecasts were initially high and were playing catch up well into the melt season. Whereas in 2023, with those good SWE estimates, the forecasts were on track early and stayed good. This relationship between the accuracy of water equivalent measurement and the ability to have an early accurate forecast is demonstrated on the right plot, where snowpack error directly relates to forecast error. Some scatter, again, future weather being a critical unknown, but that positive relationship between forecast and snowpack error tells us that there's some missing information here that we can provide to really give us the ability to tighten up our forecasts. Importantly, to make them less variable year to year so that we don't have to hedge operations quite as much. But again, this is the motivation behind ASO to measure snow water equivalent, also snow albedo at high resolution and high accuracy throughout the entire watershed, building on that existing backbone of manual and automated measurements from the NRCS. Combining all of these data streams with physical modeling of the snowpack and the hydrology, integrating these data streams in real time, and then doing all of this in an operationally targeted program with rapid data product development and forecast generation. We started this project in 2013 at NASA JPL, and about 5 years ago, tech transferred out to our current iteration, which is Airborne Snow Observatories, Inc. A little bit on how we're processing, collecting and processing the data, and this is really important because all of this is geared towards enforcing accuracy in the data products. Again, making providing that strong foundation on which to look forward, knowing exactly how much snow we have and where it is in the watershed. Our uniform flight pattern across the watershed, mowing the lawn back and forth in overlapping data swaths, gives us a homogeneous data coverage. Our initial processing links the two instruments we have, spectrometers and LiDAR, to leverage the strengths of both in order to get us a full domain consistent and accurate elevation measurements. We then co-register the elevation measurements from our snow on flight to the previously collected snow free flight. That co-registration really is the critical step that minimizes or eliminates bias in our depth measurements and gives us the ability to quantify the uncertainty in our snow depths, which is we're typically at very small to zero bias and on the order of 1 to 2 centimeters uncertainty in snow depth. We then need to combine with the modeled snow density in order to get to water equivalent. That snow density is produced by the iSnowbow model, which ingests the snow depth measurements. Snow depth is a critical part of snow density. So we're really keeping the model on track with those same depth measurements. And then we do validation and, if necessary, bias correction of those density modeled densities compared to in situ measurements from SNOWTEL, from snow courses, or other field data. That then allows us to produce a water equivalent at reliably high accuracy, basin-wide, at a 50-meter resolution. some more images of what some of these data look like. Here's the Blue River from 2019, 2023, with the deeper snow and the blues. And this is an mid-April flight in the Blue River, and then moving into later in May. Importantly, as we get into May, and we start to lose information from the snowtail sites as they're melting out, we're still able to capture the water equivalent volume remaining in the basin, which can often be a substantial fraction of the total snow melt, still persisting late into the melt season. Once we have this spatial picture, we can then use it any number of ways, and that's one of its powers. We can use it at full resolution and ingest it into various forecasting platforms or modeling platforms. We can divide it up by elevation. That's what the top left is showing, the two different April and May flights, the water equivalent volume by elevation. We can look at it by elevation and aspect, like the top rows plots are showing, and again, compare and use in tandem with the snowtail network. In this particular example, in 2023, the 4 snowtail station average in the basin was 15 inches in mid-April, and we showed 183,000 acre feet. The prior year was almost the same number from the snowtails, but about 20% less water equivalent. So this additional information really is something that can support better forecasting or less variable forecasting, and also directly inform water management, like Nathan will talk about here in a bit. Keep mentioning forecasts. These data obviously can be assimilated, used in a runoff forecasting schemes. We've been working closely with the Colorado Basin River Forecast Center. They're producing experimental forecasts using their system and replacing the water equivalent in that model system with ASO observed SWE. And we've also developed our own forecast system based on the WRF-Hydro model. And I will hand it over to Dave Gotchis now to run through some of the details there.
Great, thanks, Jeff. Apologies for any background noise. The co-working space I got to does not have an attendant today to let people in. So in the coffee shop, Jeff, I assume you can still drive the slides, and just let me know if the background noise gets to be too much. I can try and step outside. So yeah, we are using, next slide, please. We are using the WRF-Hydro modeling system, which is in the lexicon of hydrologic models, physics-based, pretty high resolution, massive energy conserving model. Our goal here is to try to represent at an appropriate scale the physics processes that drive snowmelt runoff, and provide meaningful water forecasts. I'm not going to go into all the panels here, but suffice it to say, a lot of data goes into parameterizing this model. And then on the back end, after the model gets calibrated, look at historical data, we end up with a suite of model outputs. Those model outputs include spatially distributed maps of snow water equivalent, snowpack thermal structure. We have a multi-layered snowpack model in there, which handles snow aging, some aspects of snow albedo change, and so on and so forth. Soil saturation, shallow and deeper aquifer processes to a degree, and evapotranspiration, sublimation. So a number of these products get generated from the model. We try and generate meaningful basin integrated as well as spatially distributed analysis products from those that allow people to be able to track how the snowpack that gets assimilated from the ASO surveys updates the model state, and then of course how those model states evolve forward in time in a forecasting context. Next slide, Jeff. Okay, so this is the basics of our operational prediction system. The top row is really our day-to-day analysis cycling of the hydrologic model. Just some examples here where we start with curated meteorological data from a number of different data sources. That includes radars as well as some uses of satellite data where necessary, also data from numerical weather prediction models and other types of analysis products. We use that to drive the model every day, essentially updating what the model's snowpack and hydrologic states and streamflow states are. And periodically then, over for number 4 on the top, we generate sets of forecasts from those using mostly a traditional ensemble streamflow prediction methodology. The ensemble streamflow prediction methodology samples from historical climate analysis data for our meteorological forcing. We do now blend in 7 days worth of the GFS medium range weather forecast model for the first week of these forecasts, and then have 25 different ensemble members after that representing historical years of climate forcing to try and capture some of the uncertainty in the predicted meteorology. The bottom row shows what happens when we get an ASO survey. That survey comes over and then we upscale it to the model resolution, which is a nominal 1 kilometer resolution from the native 50-meter survey resolution. That assimilation process cycles over a period of time, making adjustments to some model states, some of the model parameters, as well as some of the meteorological forcing until we get closure between the WRF-Hydro model state and the survey state. And then once we get closure between those two, we generate a new set of forecasts from the assimilated snowpack conditions. And again, create an ensemble runoff forecast. And those little accumulation plot you see in the lower right-hand corner is one of the key outputs that we generate. Next slide, Jeff. Keep going. So here's the domain that we have been forecasting in for Colorado. This captures pretty much all the basins that we're representing for this year. We've added also the North Fork of the Gunnison River into this basin map, as well as the North Fork of the Poudre River Basin. But the rest of these systems are basins we've either forecasted in the past or will be continuing to forecast for the coming year. So it's a pretty good sampling of a lot of the headwaters where a lot of the key decision making is being made. Next slide. As I said earlier, this is an example of some of the accumulated seasonal runoff forecasts. Each of the individual colored traces here is a different ensemble member generated from a particular model initialization. On the left-hand side is an open loop or unassimilated forecast, which we track throughout the season, as well as the ASO assimilated forecast. And the idea is that with the addition of the ASO data assimilation, we're able to achieve a set of forecasts which essentially converge around what ends up being the observed runoff signal, which is the black line here, earlier in the season as the season goes on, and hopefully with a bit tighter spread than what has happened in some of the earlier open loop forecasts, because we've constrained the model initialization state to the ASO survey data. Next slide. So the key way that we communicate this out to folks is through these forecast reports. Not going to go into the depths of these, but there's a number of these different products that I've been talking about, which are embedded into these forecast reports along with the narrative. They are tended to be companions to the ASO snowpack survey reports. And Jeff, if you want to go to the next slide, this is just a little bit of a blow up then of some of these products. There are maps of snow water equivalent, basin integrated, analyses and forecasts of snow water equivalent sort of in the top middle, forecasts and analyses of accumulated snow melt for various basins. This is all from the Taylor Reservoir watershed in the upper Gunnison River Basin. On the lower left-hand side, we have elevational distributions of snow water equivalent, a variety of soil moisture products for looking at antecedent soil moisture conditions prior to snowpack melt, and then looking at how the watersheds wet up and then dry down during the primary runoff season. Next slide. And then we're now starting to produce a bit longer lead forecast products for some drought preparedness and mitigation. type of applications that we've started to engage in. And these include looking at soil moisture products more in a predictive context as well, going out to the seasonal scale, as well as some of the seasonal evapotranspiration estimates that are coming out of the model. Again, using ESP-based methodology, so with a strong climatological focus, but trying to provide people information on more water budget partitioning and climate referencing, so that folks can be prepared for drought as it gives them an advance notice. I think that's it from my side, Jeff, but when we get to questions, I'm happy to answer anything more technical detail about the model or the forecast products, or just drop a question in the chat. Thanks.
Great, thanks, Dave. And to set the stage a little bit for the next part of the broadcast here, looking at case studies. Really, we've seen over the lifetime of the ASO program quite a number of different water management related activities and benefits from reservoir operations, both for multi-objective and for primary objective managements, integration with fish recovery programs and ecologic and in-stream recreation flows, flood management, early warning of unseen or underestimated snowpack to help manage runoff, etc. So we'll hear about some of these within Colorado coming up in the next segment. Two examples that I want to highlight that I think really show some important applications that ASO can support in our changing world. In 2022, in Northern California, we flew in the Feather River. This watershed, this is the water supply for the California State Water Project. Huge watershed. It takes us 4 flights to cover it. Over 60% of this watershed has been burned over the past 6 or 7 years now, through fires that we saw a lot of smoke from here in Colorado, huge mega fires. In 2022, we flew in February, and our data showed about half the snow volume that other estimates were showing, which was not exactly good news, but early warning of that certainly helped the State Water Project and its contractors get ahead of the drought game that year. Our subsequent flights in March showed that meager snowpack decreased by half, which was a bit early for that rapid of snowmelt, but that was the intersection with the recent fires, with the soot from those recently burned trees depositing on the snowpack, decreasing its albedo and enhancing snowmelt dramatically. And this was detected by our spectrometers as well. So really kind of a double whammy for the Feather in 2022, and something we're a little concerned about this year as well, evolving somewhat similarly. But really, I think a key adaptive capacity here provided by the ASO program in California, allowing early adaptation to drought and rapid snowmelt, rather than having to wait for it to express as runoff or not be there as runoff. And in this year, an interesting application in the Southern Sierra in California, the Cahuilla River. The reservoir, Cahuilla Lake, is managed by the U.S. Army Corps for flood control purposes, with water supply being a secondary goal. In mid-January, the Cahuilla Water Conservancy District was encroached into the flood control pool, trying to save water for later in the season, recognizing that it was a dry year. They decided to use one of their ASO flights of the year earlier than they typically would, in order to help support that engagement with the Army Corps. We flew on January 16th and showed 45,000 acre-feet, which was less than a third of that time last year, and quite a lot lower than other model SWE and forecast products were showing. That really helped support engagement with the Army Corps on that reservoir management. We just flew again a few days ago. This report came out yesterday, showing a strong increase from a recent storm. Still below normal, but continuing to use this time series to support that adaptive management of that reservoir operation. So really big picture here where we see the ASO and CASM program going within the state and more broadly throughout the Western U.S. is helping build this integrated monitoring and forecasting system where we have a full four-dimensional view of the mountain snowpack, our biggest seasonal water supply reservoir, that gives us the best foundation to inform existing and future hydrologic modeling and forecasting, and to serve as an important capacity to translate research and operations back and forth. Really helping us have the capacity to adapt to our rapidly changing weather and climate, as well as the evolution of our forests and watershed conditions. All right, I will stop there and take any questions, I guess, and hand it back to Paige.
Yeah, so I guess to prompt everybody, do you have any specific questions about the data products that ASO delivers, the kind of where to get them, how to access them, maybe how to use them, or anything like that? And feel free to add them to the chat later if nothing comes to mind. There's at least one question in the chat from Carl Wettlaufer. Did you note scaling of the 50-meter ASO grid to 1 kilometer, or did I mishear that? I think, yeah, Dave, you answered it well here. I think one thing to note is that 50-meter SWE is a data product that is delivered as a result of all these flights. Do you guys also deliver a 1 kilometer data product in your data package?
I wouldn't call it necessarily a data deliverable yet that is posted to the website. It's a model state. Certainly images of that come out in the reports and the various briefings that we give. Usually, what we didn't mention is that after every survey, we'll have a sit down with the basin of interest and go over the results and things like that and show that. If there's interest in that for other modeling applications or something like that, at course of resolutions, certainly happy to engage in a discussion about how we might be able to share that. Broader data services are certainly something we're working on at ASO for a variety of different types of data dissemination, but the flagship product is certainly the 50-meter SWE product right now.
Yeah, and just a reminder, I put this in the chat, but the data portal to actually access these, besides if you're on one of the email lists already, is this freely accessible data.airbornesnowobservatories.com website. You have to create an account, but the account's free. And then you can download all historic data going back to 2022, or do you go further back than that for Colorado?
It's 2020. Prior data that was collected under the JPL NASA program is hosted at the National Snow and Ice Data Center. I'll put that link in the chat here in a second. Paige, I'll add one more note on resolution. So we have snow depth at 3-meter resolution, or spatial resolution, and our SWE is at 50-meter resolution. Those two resolutions were chosen primarily to try to capture the native scale of variation in those two properties. So snow depth varies a lot more across the landscape than density does. So we measure that at higher resolution. That allows us to coarsen to the 50-meter resolution, which is a bit more on closer to the native scale of variability of the snow density. Running the snow density model at a coarser resolution allows us to save a little bit on compute time and data storage while still treating that property at its scale of variation. So that's a critical element because it allows us to coarsen. We can take that 50-meter data, which is at the scale of variability of water equivalent, and upscale it to 1 kilometer, knowing that that value at 1 kilometer is still going to be accurate. Going the other direction involves a lot of assumptions. If we were to take a measurement every 1 kilometer and then try to refine it to 50 meters, we'd have to make a lot of assumptions about how that 1 kilometer measurement represents data at finer scale. So it really is the approach that is needed in order to maintain that the snow data product accuracy at all scales.
Great, thank you. There's a question, Seth Shanahan, you have your hand raised. Why don't you go ahead?
Yeah, thanks, Paige, and thanks, Jeff, for the presentation. It's a side issue, but I noticed on one of your slides you had a table that showed runoff efficiencies for each of several years of the past related to peak SWE. And I wonder if your modeling or other work you're doing can give some insights as to why that varied so much over that 4-year period I think I saw.
Yeah, great question. Thanks. And I I always think I'm going to spend more time on that slide to talk about that panel, and I always end up skipping it because I'm talking too much. But it's a really important point, and that is often what we'll do is look at the percent of normal snowpack from the SNOTEL network and compare it retrospectively to the percent of normal runoff to produce a runoff efficiency of sorts. It's not technically that, since it's not volumes, but it gives us that kind of idea of how the snowpack compared to the prior period of record and how the runoff compared to that. And we see some strong variation in that year to year, kind of showing that the percent of normal SWE from the station data has a pretty wide variability in its utility as a predictor for runoff. One of the prime targets of blame in the past has been soil moisture. And the relative level of soil moisture year to year absolutely impacts how much of the snowmelt runoff makes it into the channel, as the thirstier soils are gonna soak up more runoff before it gets into the stream. However, leaping to blame soil moisture makes the assumption that we understand the snowpack volume well. And a percent of normal from the SNOTEL network is not a volume. And as I was going into in the first few slides, there's a lot that can happen to the snowpack volume that is not captured by the station network. And so one thing, and my slide showing the SWE in 2021 versus 2023 compared to the forecasts, it digs into this a bit more. One thing that we've been missing is the actual snow volume. And so when we think in terms of runoff efficiency, how much snow makes it into the stream, really to understand that parameter and to use that value, we need to know how much snow we're starting with. And so this is an important component to us, not just forecasting in real time, but really starting to understand the hydrologic dynamics of our watersheds. Understanding, starting from a place of knowing exactly how much snow is up there allows us to think in terms of runoff efficiencies, and then to partition those errors. If we can beat down the error in the snowpack, then we can load the uncertainties onto more difficult to measure components of the water balance, like soil moisture or like evaporation, and really help make the forecast component more reliable by confining and restricting that uncertainty.
Jeff, if I could add one point onto that. If everybody wants to look at Paige's background there, which I think we all know and love, the other issue related to this runoff efficiency relates exactly to what's going on in Paige's background, which is, if that snowpack is down in the forest a little bit more proportionately, down in the soiled forest more, that runoff efficiency may do something. But some years, as Jeff pointed out, we don't have a lot of snowpack at some of those lower elevations that are being sampled well by the stations, maybe down in the soiled forest, and disproportionate amount of the basin snowpack is sitting up in a high elevation area, like what sits behind Paige, and that has an inherently higher runoff efficiency. So it may look like we have a really low snowpack, but we get a disproportionately high amount of runoff from that because of the land cover type or the elevation at which that snowpack is sitting. And, we see that a lot in the California areas that we work in, high Sierras, granitic, high elevation areas, but we also see it in Colorado too. And so that spatial patterning has a big impact on that runoff efficiency in some years as those patterns change from year to year.
Well, thank you guys for the detailed answer. And obviously, I'm not going to cut you off for the whole duration of this, but I do want to move on through our agenda. If anybody else has other questions, they want to raise their hand or throw it in the chat. Whenever we have a pause, we can get to them. But with that, I want to move kind of back to sort of where this group came from and specifically talk a little bit about the Colorado Airborne Snow Measurement Program. And yeah, kind of how this stakeholder group came to be and really what the direction is of promoting ASO flights and the Streamflow forecasts across Colorado and Colorado tributary areas. So just generally, CASM is the Colorado Airborne Snow Measurement Program. Really, we're a loose group of stakeholders. It's all of you. I think our email list is approaching 200 people now. But as you saw in the previous Mentimeter survey, we have people representing local, state, federal, nonprofit, private entities, and everywhere in between. A lot of people have an interest in this, and use it to varying degrees of kind of integration with their system. We have a core planning team that meets every other week that is primarily made up by the entities on the right here. So myself at LRE Water, ASO Inc., and then the Colorado Water Conservation Board, Denver Water, Northern Water, the Colorado River District, Dolores Water Conservancy, and St. Vrain and Left Hand. And I'm sure I'm leaving some people out who are often on those calls, but this group has been functioning for about 5 years or so, and I'll go into the history a little bit, just helping coordinate flights, find funding, and educate groups like yours, groups like this group we have assembled here, on how to apply ASO data to your decision-making year to year, or for what other purposes you use it for. We also provide help to integrate data into the last mile models that you might use. For example, a water resources or a reservoir operations model. We have resources that we can help make that connection and sort of take a Streamflow forecast to help you make that last mile decision if that's not something that you're already kind of well set up to do. We generally provide quarterly updates and have a stakeholder meeting probably twice a year. It's not really consistent, but we usually try to have one like this one before the runoff season begins and before ASO flights start in earnest so people can be ready for it. And then usually into the spring, we'll have a wrap-up meeting. There are other meetings that sort of happen throughout the runoff season, specifically in basins that are getting ASO flights. But the CASM program has kind of this general overview of sort of education and outreach. And the link that I threw in the chat, coloradosnow.org, is our site. That will have the latest updates. We also aggregate all the data products that are available from ASO and from other sources like the Colorado Basin River Forecast Center. Cody, I think I saw Cody Mosier on this call. Thank you, Cody, for producing experimental ASO-informed Streamflow forecasts that people can use alongside CBRFC or ASO forecasts for, to see a product that they're familiar with. Quickly, kind of the mission and vision of the CASM program generally is to enhance water supply management and deepen the understanding of hydrology across Colorado by leveraging advanced airborne LiDAR snowpack measurements and complementary technologies. So it's a bit of a mouthful, but really we want to help you all make better decisions, and we think ASO is one of the best ways to do that. And so promoting that technology, helping find funding, helping coordinate flights, and then helping you all actually use it is our main goal. And that happens through a number of kind of ongoing visions that we work towards. That's improved water management and decision support applications, general advances in hydroclimate science, and then equitable program administration and sustainable funding. Number 4 is, I feel like we spend an outsized amount of time working on number 4 because that's the hardest one. But at the same time, we're now in year 5 of this program, and we see continued investment on the part of the CWCB to support this. So quick history. 2019, we were founded in the halls of Water Congress over a beer. Hey, wouldn't this be a good idea if we got together and collectively tried to fund some of these flights? And then over the next 5 years, we've acquired snow-free data, as Jeff pointed out. A snow-free baseline is required for any basin to receive ASO flights, and we've grown that snow-free data over time. On the plot on the right here, you can see the red line. The jump between 2021 and 2022 was from a water plan grant to fly a large portion of the state and collect snow-free data so that snow surveys were available whenever we had the funding year to year. Over 23, 24, and 25, the CWCB has continued to invest a significant amount of money through the projects bill, and that Eric will talk about a little bit later. But that just shows the support both at the state level as well as the level of interest from groups like yours for promoting this program. One thing to point out on this plot on the right, so the red line is our total snow-free data collected so far. The black dotted line at the top here is really our goal, and that represents the average April 1st SWE sort of coverage statewide the April 1st coverage statewide in an average year. So we'd like to get to that point. There are a number of basins that may never get flown because they don't have a large enough tributary area to sort of make the flight worth it. But we're working towards this goal of flying the entire state's snowpack and getting the most accurate measurements of SWE and associated forecasts as we can for every stakeholder across the state. So that's where we're headed. The line is sort of slowed down a little bit, but not to say it's stopping. And this is just a reminder that we couldn't do this without you. There are a number of groups. Actually, Eric, do you want to talk to this slide? You just turned your camera on.
I was just turning my camera on to prepare for my section, but yeah, we absolutely could not do this without the stakeholders. Paige mentioned that in 2019 is when CASM officially formed, but prior to that, CWCB had been working with ASO and they were part of NASA and JPL back in 2014. And before ASO went private and before the stakeholders were involved, we've been talking about how do we expand this. CWCB was not able to get a large enough budget and a large enough internal sort of interest to expand in such a way that we've been able to expand with all of your input, with all of your help, and all of the financial contributions. This year, we've got 33 different funding partners, which is just absolutely wild to me, and we'll go into that later in the presentation. But I just wanted to stress the point that all of the stakeholders are so important to anything that CWCB does. It's because of you and your voices that important things actually get traction, and we can start to expand all of these different programs at the state level that you all need. And it's you vocalizing that need that allows us to help out a lot more. So I just wanted to put that in there.
Yeah, thank you, Eric. And just a reminder, while this is a state and federally funded program, 23% of the funds last year came from local agencies with contributions ranging from literally from $1,000 up to a $200,000 plus. So we need your support. That's what makes this happen, and that shows us the interest. And Eric, we have a duplicate slide here, but we can talk through kind of what's coming and then kind of come back to it a little bit later. So if you want to talk through this slide, you can.
Sure. So now that we've talked about the what as far as the data goes and what CASM is, I'm going to go into the where before we get into the who of the case studies. So this year we've got 20 flights that are planned, which is awesome. It's the most snow on flights we have ever had in the program. It's a $4.5 million program. Like we mentioned previously, 33 different funding partners have come together to make it happen this year. I do have some news. I won't call it one way or another, but due to the recent freeze and review of the infrastructure, I can't remember what the IIJA stands for, Infrastructure Investment and Jobs Act funding, we're kind of in a hiccup with the cash investment that the Upper Colorado River Commission was going to give us. So we're still waiting on word for that, but you'll notice that Dolores and Yampa are pending at the moment, and that is why. So we should know within the next couple of days what the status of that funding is. It's been changing rapidly, so that's why those two are currently listed as just pending. However, the rest of the flights that you see, or the rest of the basins that you see on that map in green, are indeed being flown this winter, which is awesome. And we will be kicking up the Flight Coordination Committee. That is a subcommittee of the Colorado Airborne Snow Measurement Program of all the folks receiving flights in their basins. And purpose of that is we set aside an hour every single Monday to help you have conversations with ASO staff on when you need these flights done. We're going to change things up a little bit this year. We're going to split it into two parts. So the first part of that hour is going to be focused on coordinating these flights, making sure that you get the data that you need when you need it. The second part is going to be an opportunity for you to have a dialogue with ASO staff about previously flown data points. So we're going to change it up a little bit this year, but those will be coming soon. And if you're already on the Flight Coordination Committee, you'll be getting an email from me later today. If you are not and want to be, please send me an email so I can make sure that you're captured.
Great. Yeah, thank you, Eric. And yeah, anybody who is not currently but wants to be included on the Flight Coordination Committee for those kind of statewide meetings that are coming up shortly, feel free to throw your email in the chat, or just email Eric directly. Yeah, so we've got a lot of coverage here. One thing worth pointing out on this map, so green is all the areas that are slated to be flown without any hiccups. Sort of the orange areas, Yampa and Elk and Dolores, are the ones that are kind of pending this sort of federal funding hiccup. And then the brown areas, just to point out, these are other areas where we have already acquired snow-free data and could fly, assuming we had stakeholder interest in funding. And the goal is to cover as much of the state in that, or as much of the sort of gray background area that represents sort of April 1st snowpack in that brown. So you can tell there's quite a few areas that have April 1st snowpack, but may not make sense to collect that data. But there's quite a few areas notably missing from this. So we're trying to expand our coverage. So if there's other areas that you're interested in ASO flights happening in the future, maybe a year plus out, but don't currently have snow-free data, please let us know. So with that, we're going to transition shortly to our case study section, and we're almost exactly on time, which is amazing. But again, coloradosnow.org is the site to track basically everything that we're doing in real time: flight plans, educational materials, an email list with updates. We really try not to spam your inbox. I think we send about one newsletter quarterly or so. So don't feel like we're gonna clog your inbox too bad, except for my excessive meeting invites this morning. Sorry about that. So feel free to join that. And so with that, I'm going to go back to the Menti chat, and I see that there's a couple people that have joined since we had this up. But so I will throw this chat back in, or I'll throw this link back in the chat. If you just joined, please join this Mentimeter link here, and I'm going to share where we are at. So that was the last question. That was the last question we were on. Lots of answers about biggest priority, the snow and runoff season. One question we didn't answer before, and I'm very glad to see the results. What does ASO actually do? Are they cloud seeding? Are they aerial photography? Are they skydiving? No, they do high resolution snowpack measurements. So thank you for that. Once you've answered that question, we're going to move ahead a little bit to the Colorado usage case studies. And we wanted to understand a bit more about kind of how you would use this data and kind of your priorities in terms of decision making year to year, and where ASO sort of fits into that. So if everybody could go ahead to this next question. So rank the following ASO benefits by importance to your work. So there's a few people that have answered this so far, but move on forward and answer this question. There are about 14 people that answered so far, but I think, as expected, improved water supply forecasting is really the #1 goal of this, especially with this group. But we do want to understand kind of the other aspects that people are using ASO data for, and want to understand how you actually would do that. So recreation and tourism is a good example. Like we want to understand how people want how people would use ASO data to improve recreation and tourism. But go ahead and spend a little time ranking this. Yeah, I think drought management is a good one. I can think of a number of examples throughout the state of, an improved streamflow forecast would allow water providers to understand early in the season the decisions they might have to make around a pending drought. In previous years, there have been other cities. The city of Aurora, notably, used some of the forecasts that they got for the Upper South Platte to help make the decision around whether they were going to make a drought declaration. And so that kind of thing, especially in a drier year, is critically important. So yeah, getting some good answers here. So improve water supply forecasting, drought management, development and validation of other products. And yeah, I think this is what we'd expect, but just worth pointing out, the drought management side is interestingly high. And I think, understanding how people would manage drought using ASO data and the sort of associated forecasts is something we want to understand. So with that, let's move ahead to the next question. So have you used ASO data in your work before? So yeah, go ahead, spend a little time answering this. Looks like there's a few that have integrated the data and sort of forecasts into their operational models, which is really the gold standard. That's what we want to get to. Yes, but in a general way, I think ASO reports have served as a good point of comparison for other streamflow forecasts, whether they're from the CBRFC or kind of your own internal tools. So I think there's a lot of people that use it generally. But I think in a perfect world, we want to move as many of you from the pink bar to the blue bar. So if you have thoughts about that or ways that we can help you make that step so that you can either understand the data or have access to kind of a more technical product, or just in general understand where it fits in and what exactly you're looking at, we do want to understand. We do want you to reach out so that we can make that happen. And especially the yellows. No, and I'm not sure how to use it. Hopefully you'll get some ideas from this next section coming up. But if not, and you do want to integrate ASO into your decision making, again, please reach out. That is our goal, is to improve this decision making for everybody. So kind of the last question here, some people have already started to answer, but what's one challenge you faced or foresee when using ASO data for your agency? And yeah, some of this stuff we'll talk about through some of this stuff we'll talk about in the sort of program management portion of it. Some of it we'll talk about in the case studies. Timing need to be more often to be of use in my work. Also, I will need validation of use in forecasting models. I think one thing worth pointing out on timing, while the flights themselves are limited to 2 to 3 per year, depending on the basin, and Jeff, maybe you want to chime in here a little bit about kind of the improved representation of SWE after that first flight happens, because you don't necessarily need the best data doesn't necessarily come from having, flights every week, for example, but just having flights in your basin and the resulting data products of that go a long way towards improving the streamflow forecasts and the SWE measurements you have available. And ASO actually delivers a weekly streamflow forecast product and regular updates to the sort of snowpack. So yeah, Jeff, if you want to talk a little bit about that.
Yeah, certainly the number of flights per year is obviously driven primarily by the funding available. That said, we've got 2 resources that can extend that product. One is the iSnowbow model that we use to get our snow density. That's run continuously. We have a daily time series of snow water equivalent, as well as other snowpack state components such as the cold content or melt production, et cetera. And then also the time series of WRF-Hydro forecasts, and I can let Dave talk about that. The intersection with the flight data is the key thing there. Obviously, the lowest lowest uncertainty or the most certain model state is just after we insert the data from an airborne survey. However, correcting the snowpack state within the models does, effectively remove a large fraction of the accumulated precipitation input error to that point in time, putting the model in a much better and more accurate state going forward. The model accuracy, of course, will drift from that date of snowpack measurement based on, primarily is there new snowfall. That's our biggest uncertainty in model state is the precipitation inputs to the model. And then also due to other energy balance components as we get into melt season. And so each flight survey represents a model, correction, a state correction. But anytime after the initial survey of the year has been ingested, that model's in a much better state than a free running one only using weather model inputs.
Great. Yeah, thank you. So yeah, we're trying to address timing through improved modeling system. Couple other things here. Yeah, there's a couple other comments that I will probably follow up with you individually about sort of model integration, interpreting and comparing GIS layers. That's something that, a lot of the sort of forecast products, namely the reports, can address this, not necessarily the actual GIS layer comparison, but the Streamflow forecast for the points that are important for you. So, we want to make sure that, there is a Streamflow forecast at a point that's useful to you, because that may go a long way towards addressing some of your concerns here. So with that, we'll come back to the Mentimeter again. Thank you, everyone, for following instructions. And then we're going to get into some of the case studies. So Nathan, I'm going to queue you up, but we have a number of ASO usage case studies we're going to talk through, and we're not too far behind on time. We're at 10:15, so I'd ask anybody who's giving a case study to try and sort of keep it to 10 minutes. I won't pull out the hook, but yeah, try to stay on topic. But yeah, Nathan Elder from Denver Water is going to talk a little bit around some of their uses of ASO data recently. So I'm going to stop sharing, and Nathan, feel free to jump in. Saw you here.
All right.
Great. Thank you. Go ahead.
All right. Thanks. Yeah, I'm Nathan Elder. I manage the water supply for Denver Water. We've been using ASO since 2019, and we've got a couple goals there. One of them to improve our operations with improved forecasts, and also using it as a climate adaptation tool. So as we see climate change, getting a better idea of where that snowpack is, how it's changing year to year. Are we seeing, seeing that snowpack move up in elevation and that rain snow line change? Today I'm going to cover 3 case studies. So we'll cover our Fraser River collection system, our Blue River collection system above Dillon, and then also the South Platte. So starting off with Fraser, this is about 20% of our supply. Don't really have any major reservoirs here on the west slope. It's 34 miles of canals, pipes, and tunnels that funnel all of this water to the Moffat Tunnel. 30 separate diversions there and 6 sub-watersheds. So in this area, historically we've had really one snowtail there at Berthoud Pass, and then in the past few years NRCS has added a few, and then one forecast point here at the Fraser. And so what we've tried to do is develop regression relationships between either that Berthoud Pass snowtail or this forecast point to figure out within these other subbasins how much runoff might we see and how we can operate this system better. Because traditionally what we've done, as we start getting into spring, we just start opening all of our diversions. We collect enough water and then start shutting them all down. But I think ASO is going to help us do that a little bit more efficiently. Going back to those regression relationships, really poor R squared, don't tell us a lot. So again, up until the last few years prior to ASO, we just go through and open up all those diversions. So in, let's see, I think 2023, we started getting individual basin forecasts. So this is from an April 16th flight. And so now we can start to see within these smaller areas how much water is there, and we can start making better management decisions. We can really fine tune our system. So one thing that we did in this particular year, we knew between Ranch Creek, Vasquez, St. Louis, and Elk that we had enough water to meet our needs. So we didn't open up any of the diversions up here in the Meadow Creek area. And what that allowed us to do is to hit some of our flushing flow targets. We don't hit those very often up in Meadow Creek. It's hard to get 50 CFS there if we're diverting some of that water. So we were able to hit those flushing flow targets there, meet our other needs, and then bypass water here in the Fraser. And that keeps water in this whole system through the Fraser Valley, through Winter Park, all the way down to Tabernash, keeping some more water in the river there. And again, it's allowed us just to really fine tune our operations, have a better idea of which diversions we should be taking from and where we can bypass that water. Less time for our guys in the field too, rather than going to all these sites and opening all those diversions. We can target just a few of them. So now I'm going to change over to our Blue River Basin. And so again, this is where we have the most experience going back to 2019. This is where our first flights were. So 2019 happened to be a pretty big year in the Blue River Basin. This chart shows the median of the 4 snowtells that are in that basin, and then the timing of our 2 flights. So we were targeting the peak snowpack and then the melt off of those snowtells. And what we learned that year, looking over at this other chart. So our average inflow peaks here around the first week in June, and the average inflow peaks at close to 1400 CFS. Below Dillon Reservoir, the river can really only handle about 2000 CFS. So what we have to typically do is, in big years like this, we start making pre-releases, making room in the reservoir. But with that, we also want to make sure that we fill the reservoir and have enough water to meet those multiple purposes. And so we got into June, our snowtells were melted out. We were well past our typical peak runoff, and we started to see a significant decrease in runoff. We had some storms then, some colder temperatures, and we really weren't certain if this was the end of runoff and we'd seen the peak or not. When we got our snowtail flight, it showed us about 115,000 acre feet of water still in the snowpack above Dillon Reservoir, above those snowtails. So that's high elevation snowpack. Dillon Reservoir holds about 250,000 acre feet. So we know we didn't have enough space for that, and we had to immediately go up with our outflow to Dillon. We maxed out that outflow, ended up filling the reservoir. But this whole week we were in communication with Summit County Emergency Management. We had some really good data from ASO, letting them know what was going on, why we were doing what we were doing, and it really helped us communicate the needs and help reduce the flooding risk and excuse me, for that area below Dillon Reservoir. Also, a couple things we've learned, and Jeff mentioned this really briefly, looking at pretty much the same date. One flight was April 16th, one was April 19th, 2022 and 2023. Our snowtail sites were pretty close to reading, about the same amount of snow. But we saw from our ASO flights on the same day, quite a big difference in the amount of water held in that snowpack. And, again, this really impacts our decision-making there in the blue. Now I want to switch over to South Platte. We've had a little bit less experience here in the South Platte, just a few years of data. But the important piece for here is for Denver Water. We want to use our South Platte supplies before we use our Trans-Basin Roberts Tunnel diversion. It saves Denver Water money. The water quality is different, and from a treatment standpoint, it changes a lot of our planning for chemical ordering and chemical feeds and treatment plant processes when we bring over Roberts Tunnel water. So again, it helps not only from a water supply standpoint, but also from a budgeting standpoint. And this is another watershed that we're really interested in terms of long-term records and climate change. Jeff showed the impact of fires in California. We haven't seen a significant fire in this watershed in the last 20 years, but we know it's coming, and we know it'll have significant impact on how that snowpack acts and how we'll be able to manage that water supply.
Nathan, there was a question from Angus Goodbody in the chat. I'm curious why you were not sure about additional runoff expected in June 2019, with the operational forecasts not indicating how much additional runoff to expect.
The forecast still gave us a much wider range. So, we get into that area where we're trying to make sure you fill the reservoir, you don't cause flooding downstream. So, it didn't give us like an exact number. We still had a range where we could operate differently. And if we had hedged towards, just filling the reservoir, we probably would have spilled and not been able to control that extra runoff.
Great. Is that the last of your slides, or are you still going?
Yeah, that's kind of, we can wrap it up.
Okay,
there.
great.
So yeah, it's been a great operational tool for us. We want to keep it going to learn more about how that snowpack is situated and what we can learn from that in terms of climate change. And just appreciate the whole program and what CASM's been able to do to help us out with expansion.
Yeah, well, thank you guys. Denver Water's been a longtime sort of supporter and funder of this, so we appreciate you. With that, I'll switch to Ken Curtis from Dolores Water Conservancy to talk through some of their use of this data with McPhee Reservoir. Ken, it's all yours.
Yeah, I'm gonna have to grab some slides. And you may have to tell me which control shares slides. Share.
Yeah, should be a
Try
button at the
that.
top, but yeah.
Let's see how that goes. Nope. Just a second, or we'll. Here we go. How's that?
Perfect.
Okay. Just a brief comparison of 2 years that Dolores has used this. We do have 4 years now under our belt, but and the different types of years have kind of shifted how we've used ASO. One thing I've asked Dave with his modeling, and obviously the ASO crew, is to break it up into basins, starting to get at this differentiation and elevation and how the basins react. We are primarily managing for volume relative to filling and managing inflow around McPhee Reservoir, and our basin does run from 7,000 to 14,000 feet. So in 2023, like most of the state, we had a really big year. You can see from the date shown on the left, we kind of were targeting around that early April, looking for some sort of maximum in our mind, and it shows up in the table on the right and the graphics down below on the lower center graphic, that we had about 580,000 acre feet, and that's obviously a lot more than McPhee can handle. We were filling McPhee, but then managing the releases downstream. In the 23 year, normally releases are targeted at recreational users. In the 23 year, just due to natural runoff below McPhee, we were actively involved with emergency managers all the way down the gateway, CDOT and other county emergency managers. With that said, the prime goal in 23, instead of a shorter duration between flights, we were targeting when the snow was all gone and our snow tails did zero out. Normally, we're kind of trying to capture some sort of real-time yield, getting at those different elevation efficiencies and kind of true checking snowpack versus what we're seeing runoff into the reservoir. In this case, we do have six total snow tails. 2 are a little bit newer, shorter term of record, but they still span that realm of 9 to almost 11,000 feet. So we do miss the lower and the upper elevations. With that said, the May 25th, much like was spoken about Denver water, we're trying to get the real snow on the ground combined with an efficiency of what's run into the reservoir to manage that last month of rafting and emergency response downstream. And okay, it's not going to want to move. Let's try that one. Okay. Then in 24, we had a totally different year. Obviously, much lower snow. We changed kind of our pattern, just seeking total runoff. In the early April flight, we kind of contrasted only 200,000 acre feet on the ground. And this made us a lot more concerned about some of the forecasts we were seeing. And we started to pull back a little conservatively on expected runoff, particularly around future weather. With that said, we ran a much earlier second flight, partially, partially based on what we were seeing at the snow tails, but they were zeroing out early. And in that lower center one, you can start to work on the real time, at least a snapshot of your efficiency, even though you're not sure what some of the inputs are. It does get at management of what you can expect later in the season. Longer term, we do hope to look a little bit more at where the snow's coming from. The graphic on the lower right obviously gives you aspect of where you're melting out your snow, and that correlates to the GIS layers available in the basins on the left. There's more analysis to be done there, but in an individual year, we are looking at real-time efficiencies. Clearly, the contrast between the years is shown in this slide. As would be expected, a huge difference between the 2 years. For more longer term analysis, one of the interesting thing on the later flights, there was even a little bit, does show the different snowpack on the eastern edges hanging in there a little bit above on that earlier flight, but otherwise all negative between the 2 years. And then with the forecasting tools, we obviously saw a little bit of bump there in early May, but stayed conservative based on our 2 flights. And let's see if this one shows up. And CBRFC did have their experimental forecast that came in a little bit more in line with the actual runoff by the end of the runoff season. So early warning was our big takeaway from 2024 with that limited snowpack. In 23, it did allow us to manage the releases a little bit better, but volume management was more than total volume compared to 2024. I think that's where I'd leave it, Paige. Answer any relevant questions should they come up.
Great, thank you. Yeah, good use of ASO for the Dolores. You guys have been supporting it for years, and I think more than others, really starting to integrate the use of ASO data into your decision making year to year, because you've seen a variety of year types from pretty snowy to pretty dry years, and kind of the benefits and nuances of your snowpack due to ASO. So glad to have you guys involved. With that, I think I see Heather Dutton on this call. So Heather, if you want to jump in and talk about some of what you all are doing in the Rio Grande, that would be great.
Hey, Paige. Yeah, I am trying to figure out my permissions to share. So that's an exciting new new thing. Okay, let me try it. Let me figure it out again, what the problem is. Oh boy. I don't know. I don't know if this is hashtag Mac problems or the fact that I've never shared in Teams before. So why don't you skip me and I'll try to figure it out.
Okay, that's fine. So I think I see Raquel Flinker from Colorado River District on. Raquel, are you able to present about Upper Gunnison right now? Raquel, you're unmuted, but I don't know if we can hear or see you. I can't see you yet. But your Teams is unmuted. Go figure, all of these things would happen in the middle of a big stakeholder meeting when you want everything to work perfectly. Well, Heather or Raquel, let me know if either of you figures out your sharing, and whichever one figures it out can go first.
My solution page is to send my slides to you and Eric.
Great. Do it and I'll bring them up.
Thank you.
Ken, while we're paused, Angus has a question for you. Hey Ken, what was your take on the spring weather in the Dolores in 2023 after the April flights? And did you feel the forecasts evolved as expected in the spring based on any spring precip anomalies?
Actually, that's one I would like to look back on a little bit more. Spring weather does make a huge difference in our basin. Realistically, the last few years, we've been on drying trends, but in 23, spring weather was pretty large. It's one of the reasons we pushed the flight back, as well as the snowtails melting out. We realized we were better off to catch as much as we could from those springtime precip. So I think the forecasts in 23 were better overall. But with the verification, it kind of, I feel, allowed us to foresee the end of the runoff and how we were going to be releasing downstream of McPhee. Whereas 2024, the spring precip was not near as much, obviously, but it's also embedded in those early forecasts. And so we were, to some extent, discounting future weather. So some of it goes with what the weather patterns are and what some expectation is. But in the case of 23, the volume, whether it came or didn't come, wasn't going to affect how we use water, just the releases. And so that later date helped in both cases. So yeah, you do have to play them year by year. And in a perfect world, we'd probably have additional flights to capture some of that nuance to the future precip.
Thanks, Ken. And Heather, I got your slides, so you are queued up. Just tell me when to advance the slides.
Maker. Hey guys, I'm Heather Dutton. I manage the San Luis Valley Water Conservancy District. If you were expecting Nathan Combs from the Conejos Water Conservancy District, surprise. We typically work together, and so I think it's really interesting, and it's really helpful for me anyway to come to these meetings and to hear the how and the why of why and how people are using this information, and the who. In the Rio Grande and Conejos basins, it's really a collaborative of people working together to try to improve streamflow forecasting. And so we're not as granular as individual organizational operations. Usually when we talk about it, we tend to talk about the big picture since it's all of us pulling together. So next slide, page. And this next slide just shows a map to orient everybody where we are, the upper Rio Grande Basin in Colorado. Next slide, please. And so really the challenge is that we live with a lot of variability. This basin, being the lowest snow-driven watershed in the hemisphere, really experiences a lot of variability. And so you can see there on the left the hydrograph for the Rio Grande Basin from 1890, which shows incredible variability from year to year. We also see a lot of variability from place to place. We have pretty high snowpack, snow totals up in the mountains that ring the San Luis Valley, and then the floor of the valley has the esteemed designation as the lowest precipitation in Colorado. Unfortunately, when they updated the 30-year map, we went from 7 inches at center Colorado to about 6.9. So things aren't improving. Even from year to year, when we see similar quantities of stream flow, we can see wild changes in the timing of when that precipitation shows up. And so being an agriculturally driven economy and area, and then also having a pretty robust recreation economy, these kind of 3 factors and the variability associated with each of them really make managing water in this basin a challenge. The other big challenge is that most of our reservoirs are up high in the watershed. We don't have any lower elevation reservoirs. And so we capture what we can, but then we're kind of at the mercy at run out. Next slide, please. I feel like Jeff did a great job of also characterizing, in addition to the challenges that water managers have always faced, we also have the challenge of changing conditions. the Rio Grande Basin is ringed by the Rio Grande National Forest, which manages 2 million acres. Of that, about half is dead beetle kill spruce fir trees. It's a subalpine system, and we've seen a huge amount of change in our watershed from beetle kill. We've also seen some pretty major fires. We had the Westport Complex fire in 2014, which burned 120,000 acres in our headwaters. Finally, just like the rest of you guys, especially Ken over in the Dolores, we're seeing a lot of increased dust on snow, changing our albedo. So all of these factors are changing the relationship that used to be pretty well understood, where we could model the streamflow with pretty good efficiency based on these spatial measurements throughout the basin. And now we're seeing that we really have to work together to improve our data collection so that we can deal with the inherent and the continued variability, but also the changing conditions. Next slide, please. It's pretty high stakes for us. And so our division engineer thinks that we hold the, man, I'm really sharing all these accolades that we have that are really not great, but he thinks we hold the designation as the most over appropriated system in the state. And so this just shows the period where water rights were appropriated there in the blue. You can see as they stacked over time, the basin was fully appropriated by 1900. But then we, just to really zoom in, we've got 2 water years there. One which is about 84% of average, the other was about 120% of average. And you can see even in that really good year in the yellow, not all water rights were fulfilled. And then those very junior ones only came in for a couple weeks to a couple days. And so our ability to understand what's going to come out when is pretty important to be able to allow the juniors to get any water. It's looking like this year is probably going to be a 60% of average year, so even lower than that green line. And so we'll see that it's really the senior water users that are going to be in priority this year. Next slide. The really, I think the key reason we started doing this work, Eric mentioned that CWCB has been working with stakeholders since 2014 on this, and that started in the Rio Grande Basin, specifically on the Conejos River with Nathan Combs as the driver of this. And it was this recognition that all those other things, the variability, the water rate system, and then on top of it, compact administration really set us up to where we need all the tools we can get. So this graph shows the annual compact obligation. This is the most important thing that we're trying to improve down here, I would say. I think there are maybe a lot of efforts, and maybe my colleagues would disagree, but I think the compact really drives a lot of what we're doing. And so this shows that if the blue line is the flow, the annual flow at Del Norte, we get to keep below the green line, and we have to send what's in that middle area down to New Mexico. And the big pin I'll put in this is our compact is really flexible because it's an annual obligation. And so this year, for example, New Mexico will share in our pain, but it's a challenge because it's an annual obligation. And so at the end of the year, we had to have gotten that middle area correct. And that's the hard part. And so every single day, let's go to the next slide page. Every single day, the division engineer is curtailing head gates. He's not allowing people to divert water, even if it's in the river and they're in priority. That's compact curtailment. And that is how we end up at the end of the year, hopefully hitting that mark of here's what we thought we would get. Therefore, here's what we sent down. Therefore, we're in compliance with the compact. Of course, there are some nuances there, but for this conversation, that's the challenge. That's the knife's edge that our irrigators are living with. So if Craig, our division engineer, assumes that there's going to be a really high year and he starts curtailing people early and during the peak, he might cut off some of those juniors. Going back to that graph of who's in priority when, he might cut off the juniors during their only opportunity to get flows during peak runoff. And then if he realizes, oh shoot, it's not as big of a year as I thought, he'll lower that curtailment percentage. And then the seniors are impacted.
I ran to the restroom because he was like, Heather's gonna present next. And she couldn't figure it out. Oh.
Sorry. So anyway, it's this big challenge where our division engineer is trying to figure out how to get as many people the opportunity to divert water while also meeting that obligation. Next slide, please. And so this also tells that story to where if for example, in 2008, where the April 1st forecast, we thought there was a lot of water up high. So Craig would have started curtailing people early. In reality, there was much less water than we anticipated. And so people got curtailed unnecessarily. That makes people very mad. 2009, we thought there wasn't going to be much flow. And so Craig had a low curtailment early. And then as he realized there was going to be higher stream flows, he had to then curtail people later, cutting off seniors when they needed that water to finish out their crops. That also makes people very mad. It makes people mad because this is their livelihood. It costs a lot of money. It's just, again, the backbone of our community. And so because of those reasons, this is why the community has come together to try to improve our forecasting. Next slide. We're doing that by really taking a whole hog approach. We've, again, been working on this since 2014. And so we recognize that the ASO flights alone weren't going to improve they improved things leaps and bounds, but we've recognized that we also needed additional on the ground measurements to be able to have that ground truthing. And so in addition to working really hard to try to get ASO flights as many years as possible, we've also worked with the NRCS to add additional snow tells. And then we've worked with our partners to have additional temporary weather stations, some in the wilderness, which was a big win. We also worked as a team to get a new Doppler weather radar in Alamosa. And so next slide on that. So this slide shows the difference in coverage. You can see before the radar in Pueblo shot up over the mountains. And so we had some high elevation coverage, but really no good coverage on the valley floor. Now you can see that nice pink and red shows really good coverage. And so the valley floor and those low elevation areas that the radar can see all of a sudden is illuminated. Next slide, please. We also successfully built 2 new snow tells in 2014. And so we're pretty thrilled to be able to see what that's doing this year, and also to have eyes on those areas that previously were huge gaps. And again, maybe we used to be able to extrapolate in the old watershed conditions, but as we're seeing these big changes, having additional on the ground permanent sites is really going to improve our understanding of the watershed. Next slide. So we're pretty excited that this year we were able to fund 4 flights. We'll have 2 in the Upper Rio Grande and 2 in the Caneos. And so then that ties together the whole picture on adding the additional boots on the ground and ground measurements, while also being able to have the ASO flights to help us really improve our forecast. Because I didn't want to spend a ton of time talking about exactly how it improves the forecast, because I think that all the other speakers have done a pretty good job. Jeff especially, highlighted the different examples, and Ken's were super helpful. And we have the same stories about how having the ASO flights and pairing that with the ground measurements has continued to make our forecast more accurate. I thought it would be helpful for those on the call to really have this understanding of why it's important to us, and then maybe as a way that we can learn from each other about how different areas are thinking through the use of this data. So yeah, it wouldn't be possible without a huge group. Eric mentioned the huge amount of partners, and that's very true in the Rio Grande Basin. We're a pretty sparsely populated area with only 46,000 people over about an 8,000 square mile region. And so it takes all of us pulling together. So the San Luis Valley Water Conservancy District, Caneos Water Conservancy District, Rio Grande Water Conservation District, CWCB, and the Basin Roundtable are all working together to improve or to allow for the flights to happen this year. So that's it, Paige. I've got just a pretty slide of one of our reservoirs. I'd take any questions, but want to keep us on schedule.
Heather, that was great. Thank you so much for that detailed. The why is really the point of this whole thing, and so I think, yeah, really going into the details of, how you all have come to realize that this is a technology that has benefits for you and where it will slot in. I think that's really valuable to see. So thank you for that, and also for keeping us generally on time.
Thanks for the tech support, Paige. Sorry, I'm a troublemaker, but I really appreciate it.
It's okay. We've all had our issues today. Raquel, are you? And so if anybody has questions for Heather, feel free to throw them in the chat and we'll get to them as we can. But Raquel, are you good to present? I'm seeing a face. Your Teams is muted. Here, maybe I can. Sometimes it lets me unmute people. Yeah, that's really weird. Keep fussing with it. I saw Emily Carbone is on the call from Northern Water. Emily, do you want to try and see if you can present? And Raquel, maybe you have time to buy a new computer and ship it to yourself while we're dealing with all this.
Hey, yeah, I'm happy to present now. Unless Raquel, yours starts. Okay. Okay. Yeah, I'm Emily Carbone at Northern Water. So should I share my slides, or have you been sharing them?
Yeah, if you could share your slides, that'd be great.
Okay. One sec. Can you see that all right?
Yes, you're good.
Okay, cool. All right, so yeah, I'll just talk about how we've used ASO in at Northern, and some of the decisions that it helps us to make in the Upper Colorado headwaters and also on the Front Range. So I think most of you are aware of Northern Water, so I won't go into this too much, but as you probably know, we are the Northern Colorado Water Conservancy District, and we cooperate the Colorado Big Thompson project with the Bureau of Reclamation, and we deliver water across the divide. And the green shaded area on this map is our delivery area. So the project delivers water to over 1 million residents and over 600,000 acres of irrigated farmland. And so the project is made up of 12 reservoirs and 6 hydroelectric power plants. So there are a lot of important decisions that have to be made to operate the system efficiently and effectively. So that's why the ASO data is helpful for us. So some of the decision-making applications that the ASO data is helpful for us is reservoir operations, like deciding whether and when to pump Windy Gap and Willow Creek water and avoid unnecessary pumping costs, deciding when to make preemptive releases to avoid flooding, optimizing deliveries to the east slope, things like that, and then setting the annual CBT quota, which is the amount of water that is allocated to each water user in the CBT project, and that's done by our board, and I'll talk more about that later. And then optimizing power generation, so timing Adams Tunnel operations to optimize power generation on the east slope. And then there's other environmental and watershed applications as well, such as the Willow Creek fire. The ASO data has been helpful in helping us to track how the snow melt has changed since the fire. And then this is just showing the basins of interest to Northern Water. So we have 4 basins on the supply side, so on the west side of the divide, and then 4 basins on the east slope. And so those on the west slope, the main one is the Upper Colorado, so inflows to Grande and the Three Lakes. And then Willow Creek is another important one as well, and the Fraser and Blue River basins are important parts of our supply as well. And then on the east slope, so these are the basins that we deliver water to. So they include the Poudre, the Big Thompson, St. Vrain, and Boulder Creek. And then so at Northern, we've been able to get flights on the west slope since 2022. We had 2 flights a year in 22 and 23. And so we were targeting 1 peak suite flight in April and then 1 in mid to late May. But recently we were awarded a grant from Reclamation for 2024 through 2026. So we were able to do 3 flights a year. And this allowed us to add an additional flight earlier in the season. which is really helpful for us. So in addition to that peak sleeve flight and the later in the season flight for after the snow tails have melted out, we were able to get a flight in late March. And so that is able to inform our April 1st forecast, which is a really important decision-making time for us. And it also allows us to begin assimilating the data into the models earlier on. So we're able to have that model data impacted by the ASO data throughout the for a longer period throughout the runoff season. So last year we got a flight at the end of March, in addition to that peak sweep flight and late May flight, and we're hoping to be able to do that this year and in 2026, depending on the federal funding. So on the east slope, again, we look at the Poudre, Big Thompson, St. Vrain, and Left Hand and Boulder Creek basins. So we've been able to get flights on the Northern Front Range thanks to the effort led by St. Vrain Left Hand Water Conservancy District. And they led this initiative to get flights through the Northern Front Range in 2023 and 2024, and they're also planned for 2025 as well. So that data is important for us because we use both the supply and demand data to make our operational decisions. So we've started integrating the ASO data into our operational forecasts. So in addition to using the ASO data more qualitatively and comparing it with or using it to guide our other snow products, we integrate the ASO data with Streamflow forecasts in a few different ways. So we look at the CBRC experimental forecasts, also the WRF-Hydro forecasts that have the ASO data assimilation. And then we also integrate it with Northern's in-house Streamflow forecasting models and procedures. And then there's also the potential for research projects and other experimentation with other forecasting models. So lots of potential, and we've started tapping into that, and it's really interesting to be able to see the results of all of these forecasts. So now I just want to talk briefly about how the ASO data was useful this year or last year. So first, the Spring Symposium is a big meeting where Northern invites all of our water users and stakeholders, and a big part of it is to discuss the hydrologic conditions and considerations for the quota, so that annual allotment to our water users. And so this meeting can be a struggle for us because we need to have up-to-date hydrologic data, but it's very early in the month of April. So that's before a lot of the final data and Streamflow forecasts are available. So these graphs just illustrate how we present that information. We have the final data from March in there, and then we have an estimate for what we think the April 1st data will be, since we don't have the final data. But the ASO data and the forecasts that use the ASO data from our late March flight in 2024 were really useful for this because they were available in time for the symposium. So we could use that in addition to the estimates. So the Grande inflow and Willow Creek forecasts were produced by WRF-Hydro were very similar to our preliminary forecasts using the estimated data. And so that gave us more confidence in these preliminary forecasts and in presenting that data to our water users and starting to talk about the quota. So the CBT quota is set at our board's April meeting, and it determines how much water is allocated to each water user. The board makes this decision based on both the west slope supplies and the east slope demands. So that's why the east slope flights are important to us as well. The late March flight is valuable because it informs that April 1st forecast and also the staff recommendations for the quota, while the peak sweep flight is in mid-March or mid-April, so that would be too late to inform that discussion. And then another thing that was helpful this year was for preemptive releases out of Lake Grande. So Lake Grande is our largest storage reservoir in the CBT project. It's so the project isn't a flood control project, but we try to prevent flooding when possible. And there's no flood pool in Lake Granby, but there are some structures downstream that are flooded if we don't make enough preemptive releases when flooding becomes a possibility. But on the other hand, if we release too much water preemptively and then Granby doesn't fill, then that's a hit to our yield. So more accurate forecasting and snow data is really helpful in planning these preemptive releases. So in early June in 2024, preemptive releases were being made out of Granby, and Northern Reclamation were deciding how much water to release. And then the late May ASO data helped us to determine that there was more snow about the higher elevations above Granby than we realized, and that the flows would be higher than the June 1st forecasts indicated. So that kind of helped us to, in that discussion about the preemptive releases out of Lake Granby. And these are just some pictures of the ASO data in the Fraser Basin. And that's all I have. Yeah, feel free to put questions in the chat, or you can contact me at my email there, ecarbone@northernwater.org. Thank you.
Great. Thank you, Emily. And while we are at 11, I think the stakeholder or the case study part of this is probably the most valuable, or a very valuable part of this. I think we're going to keep going past 11 for this portion of it. So Raquel, if you're...
Can you hear me?
You haven't smashed your computer yet. Okay, I can hear you. Can you share?
I do hope I can. Can you see it?
All right, success. Yeah, go ahead.
And I heard Brandon walked into my office. He's like, "Is everything working?" Because I guess Heather also was having technical issue right when I stepped away from my office. But anyhow, here we are. So hi everyone, I'm Raquel Flinker. I'm with the Colorado River District, and I'll be presenting on how ASO has been used in the Gunnison Basin and what our plans are for this year, which is exciting because we have a flight that has never been done before. And Sonia Chavez with the Upper Gunnison River Water Conservancy District is really the one leading most of this effort. We worked together on a grant application last year, and we're trying to look at the basin, I guess in a broader sense, with some of the conversations and some of the reservoir operation challenges that happened in 2023 that I'll explain a little bit further. So just to provide some context, the green circle is what the Gunnison River Basin and what we're going to be talking about for the next few minutes. The Gunnison River provides over 40% of flows to the Colorado River measured at the state border between Colorado and Utah. And there are three key reservoirs that I'll be referring to throughout this presentation. So the first one is Taylor Park Reservoir that has a capacity of around 100,000 acre feet. Then Paonia Reservoir, which is on the North Fork of the Gunnison. It's a smaller reservoir. The active capacity is around 15,000 acre feet. And the Aspinall unit, which encompasses three different reservoirs, including Blue Mesa Reservoir, which is the largest reservoir in the state of Colorado. And it's on the Gunnison River. You can see it here with this yellow star. And the three combined reservoirs are around 1 million acre feet. So really the challenge in the Gunnison Basin in terms of river forecasting is, and you can see here on this table, there is inaccuracies, right? As all others have shared. In the Gunnison Basin, the error and this is average error from the May 1st forecast. So it predicts April through July runoff, and Paonia Reservoir has an average error of around 20%. And that is equivalent to around 14,000 acre feet. And when the reservoir, really the active capacity is around 15. So this at times can be pretty significant into when the gates close and when they start to fill. Taylor Park Reservoir, east at Almond and Blue Mesa Reservoir have lower average errors around, varying from 11 to 14. But as an example, Taylor Park Reservoir, the error of 11,000 acre feet, it translates to 2 weeks of flows at around 400 CFS, which in a couple of slides, you'll see that this can be pretty significant for the Taylor River and how decisions are being made on releases from that reservoir. And then Blue Mesa Reservoir, average error around 70,000 acre feet. And this can impact the year type for Blue Mesa Reservoir, and the year type is what determines how releases will be made out of the reservoir. And so if that's far off, or at times not even very far off, it can put the category at a different year type and change the amount of releases and how long peaks should last during the spring, so on and so forth. So this is the part of what ASO helps is to inform forecasting and make it more robust and inform some of the reservoir releases. So just as background, Taylor Park Reservoir was built to provide additional irrigation water for the Uncompahgre project, which is in the Montrose area. But when the Aspinall unit and Blue Mesa Reservoir came in, there was an exchange agreement between Blue Mesa Reservoir and Taylor Park that really changed the way Taylor Park Reservoir could be operated. Instead of being operated solely for irrigation uses in the Uncompahgre Valley, it could then be managed for local interests, local recreation, environmental, and irrigation needs. And better understanding snowpack can really inform that group's decision making on how to release water out of Taylor Park. And this group is the Taylor Local Users Group, or TLUG, and you can see it's composed by many different stakeholders and interests. Here's an example of operations out of Taylor Park, but you can see that in the fall, releases are at around 300 CFS. So at the previous slide, when I had mentioned the error and how it could translate to around 400 CFS for 2 weeks, you can see here how that can really change the flows in the river. And this becomes pretty critical for meeting recreational flows and irrigation needs. And so in the last few years, having ASO data has at times changed the way releases were made out of Taylor Park. And what has happened in the past before ASO data was available is that at times releases were higher than they should be if we had a crystal ball. And so you released more in the summer, and then when you got to the fall, you were having to cut back and at times impact recreation and irrigation uses to ensure that you stayed at the end of year target, which is part of how Taylor Park Reservoir is managed. So that's how ASO can help Taylor Park Reservoir operations. And then moving to the Aspinall unit, and just to locate ourselves. So Blue Mesa Reservoir is here, this yellow Star, Taylor Park here, Paonia here, North Fork of the Gunnison. And the way Blue Mesa Reservoir is operated, really there are two main drivers of how it's operated. The first one is the Aspinall Unit Operations Record of Decision. That specifies target flows in the lower Gunnison. There's a gauge here at Whitewater, so this red star. So releases out of the Aspinall unit have to ensure certain flows here in the lower Gunnison for endangered fish mainly. And depending on the year type, which is determined by the forecast, the length and the peak of the flows are determined. So that's one key driver of how it's operated. The second one is the Black Canyon water right. It specifies peak flows and base flows through the Black Canyon of the Gunnison, which is right below the Aspinall unit, below Crystal Reservoir. And the way releases are supposed to happen is in a coordinated fashion so that you meet both the peak here in the lower Gunnison and at the Black Canyon at the same time. So you ramp up releases and you hit both of these peaks. What happened in 2023 was that flows down the North Fork ramped up pretty high at the same time as releases were ramping up out of the Aspinall unit to meet the peaks in the lower Gunnison. And there were risks and already some flooding starting to happen and a lot of flooding concerns in Delta. And so the releases out of the Aspinall unit had to decrease, and they never met the peak flow on the Black Canyon. And so then in June, when the flows down the North Fork had been reduced enough, they ramped up releases out of Blue Mesa so that the Black Canyon peak flow could be met. And, you know, that created, stakeholders were concerned about that and concerned about more water being released out of Blue Mesa than necessary, but it's what had to happen given the information that we had then. But the thought is, you know, could ASO help inform some of that coordinated reservoir releases? And this is just a picture. I happened to be there the day releases ramped up again in June, and this is Morrow Point Reservoir, the middle reservoir at the Aspinall unit, and you can see it spilling. It was a beautiful sight, but yeah, that normally doesn't happen. You don't see Morrow Point spilling in June. But it was the case in 2023. And so to better inform that, we are excited that we were able to secure funding through the State Water Supply Reserve Fund, WSRF, and that was used to fly a snow-free flight in the North Fork this last fall. And so this spring is going to be the first time that we'll have flights in the North Fork of the Gunnison, and hoping that that can help inform some of the operations of the Aspinall unit. And the East River and Taylor River have had flights for a number of years, which is really interesting too, to compare WRF-Hydro modeling versus CBRC's modeling. And there's a lot of research happening in the Upper Gunnison that this feeds into as well. So this is really my final slide on why these ASO flights are important in the Gunnison to help to optimize reservoir storage and operations, endangered species compliance, improve drought resiliency, and hydroelectric power generation, and ensure that it can inform research and inform practices around forest vegetation and timing of runoff, climate resiliency. And I think I'll leave it there, but happy to answer any questions.
All right, Raquel, thank you for that. Yeah, really good to see us having enough coverage to get most of the inflow for the whole Aspinall unit and Blue Mesa. I think we'll see more improved sort of operations and forecasts as we as those are used more and more. So we're behind our initial schedule, but I think we're still on target. And I wanted to remind people, because some people have sort of come and gone, come back to the Mentimeter poll briefly. And we are into the sort of program development and growth opportunities portion of this. So thank you to all the speakers who talked through case studies. I think every year we do this, there's more and more who are integrating the data more, making better decisions, and really kind of getting their arms around how this product is kind of the future of Colorado's snowpack monitoring network. But I wanted to talk a little bit, I wanted to pivot a little bit as we sort of start to wrap up today's session and talk about program development and growth opportunities for CASM generally, and kind of take the group's temperature. So again, the Mentimeter chat is here at the bottom, so go back in. But where, and some people have answered this, but where should CASM and ASO expansion efforts focus next? So we have a few, range of answers, but integrating with forecasting tools. I think seeing a lot of those, seeing a lot of those responses is really heartening, because that means people are a step past, what is ASO? Okay, now we have this data, we have good snowpack measurements. Now, really, where do we plug it into the tools that we already use? Integrating, increasing flight frequency in more basins and data accessibility, also very important. But really integrating with forecasting tools and figuring out how to do that is a key goal of ours. So good to see people respond to that. So we'll move on to the next question. So what factors most influence your decision to use ASO data? Relevance to specific basin and sector. I think that makes a lot of sense. It's not really useful to have an ASO measurement in a different basin than yours, though we are trying to expand that. As people are responding, I'll just say a few comments on cost. I think generally that point is taken, that the flights themselves are expensive and it takes a collaborative funding program like this to make them happen. But I think more and more we see federal and state matching funds making that cost more accessible to smaller users. So I think our hope is that while we do get matching funds from this broad group of stakeholders, once the data is available, the annual cost shouldn't be, the annual sort of cost to any one agency should be shrinking. And, I think pivoting to using the data and not sort of saying, well, we can't afford this, so we can't use it. I think pivoting towards how to use it now that it's available to your basin is one thing that we really want to work towards. So I guess I didn't say one way or another on what factors influence your decision, whether those are good or bad factors, but data accuracy being a good factor to use ASO data seems, that's heartening. Timeliness, consistent availability, accessibility. So, okay, good to know that this data is accessible. Move on to the next slide. So open-ended response. If you could change one thing about the current ASO, and I say ASO and CASM program here together, what would it be? A few responses here, but definitely add more. Cost and funding structure. I think we're working on that. We're trying to figure out how to make it sort of more fair while making the data as available as possible. More flight availability so basins don't have conflicting needs. So whoever wrote this one, one thing that we do try to do, Eric mentioned the flight coordination committee meetings during the early that are going to start up here in a couple weeks. That's really how we resolve that right now is, you show up, and if you have a strong feeling about when you need a flight because of a particular decision, a lot of times we can accommodate that, or there's enough flexibility in kind of other stakeholder needs that we can usually make that happen. So hopefully this flight availability with conflicting needs is resolved through the Flight Coordination Committee meeting. Now, that said, weather isn't something we're ever going to be able to totally solve, so there's always going to have to be some flexibility. But I think if you go into a season knowing when you're going to want the flight because of when you're going to need to make a decision, I think if you go into it knowing that, that contributes a lot towards solving this problem. We need to offer products that the lay water user can use as well as the managers. Yeah, and I think the ASO reports do have some amount of this. There's keys, forecast points in basically every report that shows those forecasts, the forecasted total runoff for a given basin. But so depending on what that lay water user actually needs, I think as we get more and more, that maybe, I think Jeff and Dave, maybe at some point putting the forecast in the context of other years' total runoff might be a useful piece to add to those reports. I think we're late in the game to do it now, but for the key runoff sites, saying here's your forecasted stream flow and here's the range of historic years. So something to kind of put that in people's minds. Yeah, expansion, snow off data for wider basins. So state adoption of program. All right, we're going to get into this in just a sec. So thank you everyone for your responses, and we'll get into the, Dave, if you want to say anything about that, what I just mentioned. Okay, great. So let me switch gears here to back to the presentation. So Eric, if you're around, yes, this is a repeat slide, but it's worth reiterating what we're doing this year. And then your other slide's next.
Yeah, thanks, Paige. So again, just to bring it back home to what is happening in 2025 before we talk about the extended future. This year's program is a grand total of $4.5 million. That is the most we have ever had available for this program. And like that 33 funding sources suggests, it's a combination of funding sources that I'll get into on the next slide. But we're talking state funds, federal funds, local funds, basin roundtables are involved. It's really been a massive group effort to get all these flights done. Again, just wanted to point out Dolores and Yampa and Elk are both pending UCRC investment. I did get an email in the middle of this that gives me a little bit more hope. So if everyone would just cross your fingers, toes, and eyes, hopefully we'll be able to get something more solid later this week. But things are looking up for that. So yeah, the green basins we're flying this year, that lighter tannish color are snow-free basins that we could expand to if we've got funding available for snow on flights moving forward into the future. And yeah, those darker tan colors, the Yampa and Elk and Dolores, are pending the UCRC investment. So next slide, Paige. All right, immediate future. Someone was reading the script when they put in state adoption of the program, because House Bill 25-1115, which was originally introduced very late January, went before the Ag and Water Committee last week. Yeah, this month is flying by. Passed unanimously, but that bill gives the CWCB the authority to adopt exactly these efforts. It's a really short bill. It gives CWCB the authority to administer a water supply measurement and forecasting program that would allow us to collect and disseminate data on snowpack levels, investigate the latest technological advances in snowpack measurement and water supply forecasting, and collect other data that the board determines will assist in snowpack measurement, water supply forecasting, or flood hazard mapping. So CWCB leadership, DNR Executive Director's Office, has heard you all about this need for state adoption of the program, and this bill will allow the Colorado Water Conservation Board to do just that and actually be able to provide the staff time that is necessary to really move this program forward and help us to leverage these other funding sources as they become available. So right now and continuing into the future, CWCB is able to invest in this program via our projects bill. This year for 2025, We have $2 million. We're putting $1.8 million towards the flights. $200,000 was to retain Paige to help us out with the administrative support of the program. It's become too big for the part-time that Andrew and I can dedicate to this. So we hired on Paige to help back us up and help us really maintain some consistency in the leadership of the program. Also, I saw in the previous slide, one of the responses was talking about looking at forecasting. That's also something that CASM has contemplated before, was looking at a forecasting comparison study. So part of that 200K going to Paige is to design that sort of study and help us figure out how best to utilize this data. So we've got a lot of exciting things moving forward. And as far as if this House bill passes and the program is created within CWCB, it will continue to be funded through the projects bill. We had our board approved back in November of 2024 to include another $2 million investment that would become available in July of 2025 for the 2026 season. So CWCB's board is still very supportive in investing in this program. But it's not just state funding, right? I want to point out some really cool things that are happening on the local scale. We've got the Colorado River District through their Community Funding Partnership Program. They approved $500K for a few years for this. So that is a really huge recognition of the importance of this data for their stakeholders as well, that their board was able to put forward continuous funds for flights in their areas, which that's really cool that they're doing that. And for the really super local folks, Front Range Collaborative. Scott Griebling, unfortunately, was unable to speak today, but he's working with, I think, a dozen folks right now to get all the funding put together for all of their flights along the Front Range, and that is the Poudre all the way south to the Clear Creek Basin. So they've got this really great local collaborative going on where they can bring the funds together to match with the state dollars, to match with the federal dollars. I just wanted to highlight some of the cool things that are cropping up in order to address costs. Finally, federal funding. We all know that there are some uncertainties at the moment regarding federal funding, both with bills that have already been appropriated and then potential future funding. We've tried to take advantage of Bureau of Reclamation's notice of funding opportunity for their snow water supply forecasting program. That's another thing that Paige is doing that we're paying him for, is to help you apply for those Bureau of Reclamation grants. So he's done a great job of putting together these like 80% ready to go applications. So if you're one of these stakeholders that's looking for other ways to find funding, if this notice of funding opportunity pops up again this year, we've got someone available to help you put together those applications. So that's something that we're trying to leverage. USGS has been a great partner throughout the years by providing annual funding. Department of Energy through the Lawrence Berkeley Lab has been incredible in maintaining a continuous funding source. So it's just this massive combination of funding sources coming together. And like Paige said, if we get a bunch of folks all together to collect all these funds and put things together, ultimately the cost for each one entity would go down. Now, I can't promise anything on what state investments are going to be looking like, what federal investments are going to be looking like, but the more folks we can get involved and the more folks that are benefiting from this data, the more we can share that sort of cost burden. So it's always going to be a combination of everybody doing things. But yeah, there's a lot of stuff going on at the state level as well with that House bill going through. So that was my piece for the future moving forward. Any questions?
Yeah, in the interest of keeping us going, if you have questions about funding sources or that aspect of things, or if you feel on the administration side, if you feel compelled to sort of join us and help coordinate some of this stuff, you know, the CASM planning team is always looking for more people. With that, Jeff, I have your other slide on sort of ongoing developments from ASO. So yeah, here you go.
Yeah, thanks, Paige. And kind of mixture of highlights here. We've just talked about new basin programs within the state. We also have some efforts afoot expanding in neighboring states as well. The UCRC investment is not just within Colorado, but but also in Wyoming and New Mexico, and then some reclamation funds expanding the programs in Utah. So really looking at a regional regionally expanding program that is benefiting Colorado through our participation in all of these different watersheds that flow out of the state. Dave mentioned earlier some changes and additions to our runoff forecast products and cadence this year. We'll produce the reports that Dave highlighted after each of the airborne surveys has been ingested into the WRF-Hydro model. But then the forecast update cadence will be weekly. So new forecasts every week throughout the melt season with those more detailed reports following each of the flights. There's also the integration of the GFS forecast for the near term flows as well, and a number of other developments in work there. We've tried to respond to various partner and stakeholder needs by increasing opportunities for engagement and opportunity to discuss or ask questions about any of the snow products or our forecast products. We'll continue to do so this year. Eric mentioned the flight planning meetings that will occur during the season. We'll try to incorporate some time there for discussion of recent results. We've also done a number of retrospective meetings over the past year, looking to learn some lessons and build on the successes of the past year and implement them going forward. Additionally, we're working on some enhanced data exploration and visualization tools, building a new dashboard to be able to explore not just the flight data, but the ice snowbound data and the WRF-Hydro products through a single dashboard. And we're also working on alternate methods of data delivery. Right now, you got to go snag the data through a direct download from our web portal. We're looking at working with Esri to build an ArcGIS Pro plugin, so you can access data directly through that tool if you're an Esri user. In this spirit, welcome any input or questions on products, engagement, or data accessibility. Always looking forward to tailor things going forward to meet everybody's needs. Thanks, Paige.
Thank you, Jeff. And yeah, just to kind of wrap up, because we're basically done here. Thank you for everyone who stuck with us. But just a reminder of some of the ongoing engagement activities that happened, this stakeholder meeting being one of them. The ASO workshop is currently scheduled September 9th through 11th, 2025, in person at Palisades Tahoe and also virtually. Jeff, I believe you can just sign up through your website, but I've gotten emails about it, but I don't know how to sign up to get on that list if you're a new person.
Yeah, well, we can coordinate some outreach through CASM, and sign-up's not quite open for that yet. We've just got the save the date out there, but there will be an announcement for that late spring. Gotcha.
Yeah, there's biannual stakeholder meetings like this one, or loosely biannual. Some basin-specific data delivery, email lists. There's our somewhat regular newsletter that comes out with key program updates. And also, I wanted to point out regular presentation at outreach events. While this broad group is useful, sometimes a more kind of locally tailored conversation is necessary. So if there is something that you want us to present, at, feel free to reach out. And I think there's enough people on the CASM planning team or in the ASO folks are often able to make that happen. So we can probably present at your session if you're interested in either getting some interpretation of the results that have been delivered to your basin or interested in knowing how to expand it. We can be available. One question from the chat: will these slides be shared? The actual slides won't, but the presentation is being recorded and will be shared on YouTube with timestamps. So you should be able to navigate it pretty easily to find what you want to see. And that's a publicly available YouTube channel. So with that, just a few quotes from people. These are mostly people from California, but just some quotes from water users and water district managers who've had great success using ASO data to kind of improve their decision making. And just a reminder for how to sign up for any of the email lists or data delivery lists. You can use either of these QR codes. And with that, feel free to add questions, but thanks everyone for coming. And we're right at 11:30, so pretty happy that we are pretty much right on time. But yeah, if there's any burning questions you had that you haven't had a chance to address, feel free to throw them in the chat or just unmute and ask. Nice. And I guess, I don't know that we actually mentioned this, but Jeff, when is the first flight this year for Colorado? Like mid-March-ish?
First Colorado flight will be in Colorado headwaters above Windy Gap for Northern Waters Snowflow program. And we've kind of notionally said March 15th. And over the next week or so, we'll start coordinating with Emily and other stakeholders in the basin and start to look for weather windows. So yeah, middle of March coming right up.
Nice. Yeah. 2 weeks and it all starts. All right. Well, no one feel any pressure to stick around at this point. The meeting is done. So, I'll keep the chat open for another 5-10 minutes. And then if anybody has anything, but otherwise, thank you all for coming.
Thanks, everybody.
Thanks, everybody. Really, really appreciate your time.
I've got a simple question, if you don't mind answering.
Yeah, sure.
So I get how, or I can imagine how, like snow depth measurement works above tree line. Can you describe how it works in dense forest?
Yeah. The way the LiDAR works is, it's using a laser pulse to measure distance from the plane to the ground. Each laser pulse spreads out a bit as it moves away from the laser source, and so by the time it hits the ground, it's on the order of 50 centimeters to 70 centimeters in size, that spot. And so because it's an area, not just a little point, you can have portions of each laser pulse reflected by the forest canopy. So we're getting returns from the forest canopy and measuring, essentially the height of the forest. And some of that laser energy makes it all the way through to the ground surface and then back out again. So basically a good rule of thumb is if you're standing under a forest canopy and you can look up and you can see even a speck of sky, some laser energy can get through there. So it's basically able to see through that forest canopy to the ground surface underneath, or snow surface in that case.
Okay, interesting.
And that brings up an ancillary usage, and that is, in effect, we're mapping the forest structure every time we fly. So we've got a time series of forest structure as well that can be useful for studying the evolution of that cover or the disturbance from bark beetles or wildfire, et cetera. We use those data to help inform the models, snow and hydrology models, because the forest cover is a significant impact on the mass and energy balance of the snowpack, but also super useful for specifically forest studies or monitoring as well.
Yeah. Cool. Very cool. Thanks for answering.
Yeah.
Thanks. Yeah, and Gene Vo asked, does HR 251115 need to go to the Senate and governor, or is it done? Yes. First hurdle is passed, but not all of them.
Yeah, I'm sorry, I didn't specify in the text what I meant by yes. So yeah, it still has to go through the Senate and the governor. It's not done yet. Still is going through the entire legislative process. It's just gone through those first couple of hurdles of being introduced and then going through the Ag, Water, and Natural Resources Committee.
All right. With that, I think I'm going to end it, and we'll share some slides out. But thanks for coming, guys.
Thanks, y'all.
Thanks, everybody.